Hello everyone, welcome to the solution of LeetCode problem 77 named combination. In this problem, we are given two integers n and k, and we have to return all possible combination of k numbers chosen from the range of 1 to n. And fortunately, we can return the result in the any order we want. Let's analyze the first example. In this example, n is 4. That means we are given four integers 1, 2, 3, and 4, and k is 2. So we have to pick two elements from the integer range to make the combination. So there are 6 possible combinations for this case, which is 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. Now, the constraint are the value of n can be in between 1 to 20, and the value of k can be in between 1 to n. I hope you understood the problem. Now let's move on to the solution. Now let's understand the solution. At first, we have to think what is the mechanism to solve this problem. The main approach of this problem is backtracking, but we can solve this problem by using brute force search as well. But I am using backtracking for the simplicity of the algorithm. Now, in the first example, the value of n is 4. That means we are given 4 integers for taking the combination, which is 1, 2, 3, and 4. And the value of k is 2. That means we can pick two integers from the range. Anyways, we have to explore a decision tree to understand the algorithm. At first, we are in the root position. From this current position, we can take the value of 1. Now, if we consider the value of 1, which is this, from this node, we have three choices. Either I can take 2 or 3 or 4. So from this node, I am taking 2 here, I am taking 3 here, and I am taking 4 here. And again, from this 2, we also have another choice. But wait, should we include any other value from this node? No, because in this level, we have already considered two values. One is 1 and 1 is the value presented in this level. So we cannot explore anything from further here. So this is the base condition. Now, from the root node, after considering 1 as an option, we can consider the value of 2. If we consider the value 2, we have three choices. Beneath it, we can either choose 1, 3, or 4. But wait, can I choose 1 here? No, because we have already found the combination of 1, 2. So it doesn't make any sense to explore the tree with the combination of 2, 1. So here we have to choose 3, and here we have to choose 4. So we have found another two combinations, which is 2, 3, and 3, 4. Now from the root node, we have to choose 3. And if we choose 3, we have also three possible options, which is 1, 2, and 4. But we should not include 1 and 2 because we have already found the combination of 3, 1 and 3, 2, which is this and this. So for the option 3, we should not consider 1 and 2 as an option. Now we have only one option remaining, which is 4. So we have found another combination, which is 3 and 4. So finally, we have found 6 combination, which is 1, 2, 1, 3, 1, 4, and 2, 3, 2, 4, and finally 3, 4. I hope you understood the explanation of this decision tree. Now let's move on to the code. In this code, at first we are given a function combine, which has two parameters, n and k. The return type of this function is the vector of vectors, and inside this function, we have to declare a result vector, which will store the result, and we have to declare a temporary vector, and we have to recursively call a backtracking function. For the sake of simplicity, I am naming this function as func. The first parameter of this function is our final result vector. The second parameter of this function is temp, which is the temporary vector for the caching mechanism. The third parameter of this function is 1, which is the value of 1 or the starting position of the backtracking algorithm. The fourth parameter of this function is n, which is the given input. And the fifth parameter of this function is k, which is the number of element can we choose. Now, let's explore the functionality of the backtracking function. At first, in the backtracking function, we have to check either our current temporary vector size is equal to the k. If it is, then we have found one combination. So in this case, we have to include the temp vector into our final result vector. Otherwise, we have to use a loop which iterates from index 2, and in each iteration, we have two choices. Either I can include our current value, or we can completely ignore it. If we include our current value, we have to insert the current value y into the temporary vector, and we have to recursively call the backtracking function from the next element, which is I+1. Otherwise, we can simply ignore the current value from our choice. So in this case, we have to simply pop our last element from the back of the vector. And finally, we have to return the result. I hope you understood the code. Now let's move on to the time and space complexity analysis of this algorithm. In this algorithm, the time complexity is big O of k into n to the power k, because we are considering k element from the n element to make the combinations. And in each step, we are caching the value. So the time complexity is k into n to the power k. And the space complexity is also k into n to the power k, because in the worst case, the size of our current vector can be equal big O of k into n to the power k. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.